Hey, what's up folks? Mr. Schwerman here, just making a video. Will hopefully be a little helpful when we're talking about converting number systems, specifically looking at hexadecimal, because I think that's what we've been looking at the most. So I'm going to really quickly show you how to convert from hexadecimal into decimal and binary, and then back from binary and decimal into hex. So I'm going to start by just reminding us that we have hex, we have decimal, and we have binary, and these are all different ways of representing the same numbers. And I'll start with decimal because it's what we're most used to, and I'm just going to make a table going from 1 all the way up to 15. And I should have actually started at 0 because most appropriately we are going from 0 to 15 when we're looking at hex. So I'm going to do that and give myself my 0 as well. Hex, for the first 10 digits, looks exactly like decimal. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But then 10, whereas decimal goes to the next number over, you've got the tens place and the ones place. Hex, we just start adding letters. So 10 represents A, B represents 11, C, D, E, F. And then in binary, I'll write these all out as 4-digit numbers just because hex can be represented the same as binary in 4 digits. So I'll write all 4 zeros to represent 0, and then a 1 is 0, 0, 0, 1. A 2 is 0, 0, 1, 0 because there's one number in the 2's place. Then 3, 0, 0, 1, 1, 4, 0, 1, 0, 0, 5, 0, 1, 0, 1. What you kind of see as you write out the binary numbers like this is there's this little bit of this pattern. We keep like ticking up. We fill up the 1s, and we fill up the 2s, and we fill up the 4s, and so on. So we'll just go through it. 6, 0, 1, 1, 0, 0, 1, 1, 1, 1, 0, 0, 0, 1, 0, 0, 1, 1, 0, 1, 0, 1, 0, 1, 1, 1, 1, 0, 0, 1, 1, 0, 1, 1, 1, 1, 0, and 1, 1, 1, 1 is 15. This is just nice to have as a reference because it's going to hopefully help us out. So I'm going to start. I'm just going to pick a random hex number. I'm going to use 2 digits, and I'll use a letter just because letters are confusing. C7, we'll say. So if C7 is a number in hex, I want to make sure we know how to represent it in binary and represent it in decimal. I'll start with decimal because that's probably what our brains are most used to. And I'm going to label this number underneath. We've got our 1's place and then our 16's place. So this number C7 is a number made up of 7 1s and C 16's. And remember, C is equivalent to saying 12. So there are 12 16's and there are 7 1s. And so what I just like to do is after I've labeled those out, it's really easy. So C 16's is the same thing as saying 12 16's, and 7 1s is 7 1s. So 12 times 16. I can pull up my calculator app, and it might be most useful to split screen it, which I am forgetting how to do because I am a little tired right now. That's fine. There we go. So we have 12 16's, which is 192. We have 7 1s, which is 7. So this number is 199. So C7 in hex is the same as 199 in decimal. And then we'll talk about binary. Binary is not so bad. First, what we do is we just take every digit in hex and we split it into its equivalent 4-digit binary number. So if C represents 12, that's the same thing as saying 1101, like we said here. So this simply becomes 1101. That's that 12-bit. And then a 7, as we said, 7 is just 7 is 0, 1, 1, 1, 0, 1, 1, 1. So in total, if I wanted to represent the number C7 in binary, I could just write 1, 1, 0, 1, 0, 1, 1, 1. So those are all the same number. All right, so that's converting from hex to the other number systems. Converting backwards can be trickier. We'll start with binary because we use the same counting algorithm. So if I have the number, let's say 110110110. I don't know, it's nice and repetitive. What we want to do is split it into chunks of 4. And so I will just mark these off. That's a chunk of 4. That's a chunk of 4. And then I have a 1. And I like to kind of remind myself that I sort of have these leading zeros. And they don't count, but it helps me see my 4s. And then each chunk of 4, we just have to see what it is. So this 0001, this first bit, well, that's just a 1. 1011. If we're good at our binary, we see that that's 11. You can also just look at the chart, and that is represented by the letter B, which really means 11. And then our last bit, 0110, well, that is simply 6. So the number 110110 is really 1B6 in hex. So binary to hex is just like that. Is just splitting it up into 4 chunks, and then each of those 4 chunks simply represents 1 digit in hex. There's no calculation that has to be done there. It's just splitting it into 4 digits and then transcribing that 4-digit chunk you found. All right, now get ready for the fun part. The fun part is going from a decimal number to a hexadecimal number. I've seen a few ways to do this, and I think they're all a little confusing because it's tough, I think. Let's start with something really simple. Let's say the number 18. If I look at 18, I know that that's more than 16. It's not a 1-digit number. But I also, just looking at it, I know it's like a little bit more than 16. So I could probably look at that and kind of like how we do binary, kind of game it out and say, okay, we've got the 1's place, we've got the 16's place, and I can look at that and I can say, well, obviously there's 1 16. If there's 2 16's, that'd be 32. It's not 2 16's. And if there's 1 16, well, what's left? I could just do 18 minus 16 is 2. There's 2 1's. So the number in decimal, 18, in hex, we would write as the digit 1 and the digit 2, which to our brain looks like 12, but it's not really 12. It's really 1, 2. It's a hexadecimal number that represents the decimal number 18. So I want us to sort of keep that in mind while we're looking at this procedure. That's what we're doing, is we're just finding how many of each factor, how many 16s, how many 1s, up to how many 256s. And so that's what I want to do next, is look at a number like a lot bigger than 16. It's easy to look at when it's bigger than 16. Let's try a number like 72. This one is a little bit harder, right, to game out. I could say there's a 1, there's a 16, there's a 256, and I could say, okay, there's definitely not any 256s yet. But 16s, I don't know, there's more than 1, there's more than 2, there's more than 3, I think there's more than 4, but it starts to get tough. And so you can keep doing it this manual way, and I could say, okay, what's 4 times 16? Okay, well, that's 64. Yeah, that works. So there's 4 16s minus 64 is 8. Okay, there's 8 1s, so 4 8. And I can do that, and I'll just kind of write that down so we have it. That the number in decimal, 72, in hex we would write as 4 8. So again, it can be confusing. They look similar. Well, they look very different, but they look like they could be each other. A hex number could be a decimal number and vice versa. There is a little bit of a procedure we can do, kind of a rule, an algorithm that'll help us with any size number where we don't have to sort of game it out like that. But it's a little confusing. It looks like this. Let's use 72 again. And what you want to do is you want to divide that number by 16. And people write this in kind of a weird way, and that's okay. I'm going to write it this way. So I'm going to divide it by 16. So in my calculator, I'm going to put 72 divided by 16. And that is 4.5 is how my calculator gives it as a fraction. Maybe if I was in decimal, I'll go back to decimal, I would show it as 4.5. And so what we need to do is we need to mark the quotient, like what it is, and the remainder, what's left. So 72 over 16 is 4. And then 4 times 16 is 64. Our remainder is that 8 that we saw before. But the way we are going to know that is like, so our remainder in our fraction, or our answer in our fraction is our decimal, our 0.5. So 0.5 times 16 is 8. That's our remainder. And we kind of write our remainder over here on the side. And then we do it again. We do 4 over 16. And if I do 4 over 16, it's 0.25. So my quotient is 0. And my remainder is 0.25. 0.25 times 16 is 4. And so I write that remainder over here. And then I read that upwards. So this number upwards is 4/8. And look at that. 4/8 is the same thing we found when we kind of did it longhand. So this method of dividing and writing the remainders on the side and then reading up, it always works because we're doing the same process we did when we looked at it and said, okay, there's 4 16s. It's the same process, but it's a little more systematized and it helps work for bigger numbers. I'm going to show you one more example because I personally find it very counterintuitive, and I would understand if you did as well. And I'm going to use a big number now. Let's say 5,237 to pick a number. That, I could not personally look at that and say, okay, that's this many ones, this many 16s, this many 256s. It just gets really hard. This is why having a procedure really helps. So we start, we divide by 16. So 5,237 divided by 16 is 327. So I write that down. And the remainder, which is 0.3125, and I'm just going to multiply that times 16, because that's the remainder. The remainder is the actual value, 5. And we do it again, 327 over 16 is 20 and a decimal. So I got to find that remainder, 0.4375 times 16 is 7. By the way, these decimals can get weird, but you'll know you're doing it right if you're getting whole numbers. They should all be whole numbers because it's a remainder. If you're not getting a whole number right now, you may have typed something in wrong. Okay, I still got a number more than 0, so I go again. 20 over 16 is 1. So I'll write the 16, that's 1, and then 0.25 times 16, the remainder is 4. And then last one, 1 over 16, I know it's the last one because 1 is smaller than 16, is 0, and then 0.0625, which is just 1/16. My remainder is 1. So 1475 should be the hex representation of 5237. I like to kind of go back, check my work. Here's one thing I can do is, do the, okay, 116, 256, and I don't even know what's 256 times 6 is 1536. So I'm thinking there should be 1536. So let's see. Plus 4 256s. This is not going to work. I have made a mistake somewhere. Plus 7 16s. This is not going to work at all, is it? What have I done? I've done something incorrect. Look at that. And I don't know. I don't know what I did wrong just looking at it. 5237. What did I do wrong? I don't know. Let's try again. Oh, no, I did wrong, actually. Oh, I'm just silly. I was just checking my work wrong. 256 times 16, not 6, is 4096. There we go. This is going to look a lot better. This is the 4096 place. Oh, yeah, this is going to look great. So I actually have a 4096 plus the 1024 plus the 112 plus the 5. And let's see. $52.37. Good. So that's one way I can double check, is I can just go go back forwards, let's say from decimal back to hex. The other thing I like to do is, okay, I remember that 1475 is what I was looking at, is you can just, go to Google, go to Safari, go to whatever, and search up hex to decimal. And if I pull this up, this rapid tables is a really nice one, and you can use these drop downs and change whatever you want. And let's see, so I was looking at 1475 should be the same as 5237. Let's see, 1475 is 5237. Look at that. So there you go. There's the process. I know it can be a little gnarly, but I promise if you just practice, you'll get there. Have fun, folks.